All right. Good morning, students. Now, as usual, I will always prepare a video based on our various lessons. So that persons, who probably because of poor internet access and so on, they did not get to access the class or they missed something. So this video would help you to, get whatever you would have missed. All right, we completed angles. We looked at various subheadings on the angles, such as the definition, the parts, the types of angles. We looked at how to draw angles using a protractor, and then we construct as well as bisect various angles. All right. Now, please remember there are a few angles that you cannot construct. Not a few, but there's a lot of them that would be very difficult for you to construct. So you need to know exactly which ones you can construct. All right. Whichever ones you cannot construct, as I mentioned before, you would need to use your protractor. All right. Good. So today we'll be moving on to a different topic. And I would like you, to challenge yourself. I have a few letters here. I want you to pause the video and try to figure out, what these letters are when you rearrange them to make an actual word. All right, so you can just challenge yourself. This is just a little brain teaser to get the brains up and running. All right, to get you thinking. So you can just pause the video and do that. Now, the actual topic is triangle. All right, so it is triangle. So that is what we'll be looking at today. And on the triangles, we look at the definition, we look at the parts, we look at the types of triangles. After which, we would look at how to construct triangles when given the length of one side. All right, so we will just focus on those for this lesson. Good, now there's a video here. The video is based on the uses of triangle. You know what? Why is it important for us to know triangle? Right? And we're not just doing this just to do its sake. Right? Triangles, their uses are very, very important in everyday work. Right? So I will upload the presentation so you'll be able to look at the video when you access that. Right? So I would not play it here. I would leave it in the presentation so you can get to access the video and look at it when you have time. Good. Moving on, what is a triangle? And again, you can just pause the video and try to figure out, in your mind, what is a triangle. So a triangle is a plane figure bounded by three straight lines. All right, three straight lines. Not just three lines, but three straight lines. All right, and it's a plane figure, meaning that it's flat. All right, it's a flat surface. It is not a three-dimensional shape where you can actually see an object. Right, it's a plane two-dimensional figure. All right, it has three sides. Additional information, as we mentioned, it has three sides, and it also has three angles and three vertices. Remember the angle, whenever two lines meet, we have angles being formed. So it has three internal angles, all right, and three vertices. If you can remember when we looked at angles, the point where the two straight lines meet, that was called a vertex. However, a triangle has three of those points, so we call them vertices, right? So it has three vertices. Now the three angles add up to give you 180 degrees, right? So the three internal angles, they add up to give you 180 degrees. So it doesn't matter what type of triangle it is, it will always give you 180 degrees. All right. Good. Now we look at the parts of a triangle. Right. And again, you can challenge yourself and try to figure out what these parts are. For example, the peak or the top of the triangle. What is the name given to that? Likewise, this one on the left side here, this one in the middle, this part at the bottom, and so on. Right? So you can just challenge yourself and try to figure out those parts before you go to the next slide. So these are the various parts of the triangle. All right, the parts are labeled here now. So we have the apex, we have the side, we have the altitude, which is the vertical height of the triangle, right? The altitude is always 90 degrees to the base, and it is not always drawn from the center of the base. Please understand that, right? It is not always drawn from the center of the base. It is 90 degrees to the base. Take, for example, a right angle triangle. The altitude there would be the vertical line or the vertical side, right? And that was not drawn from the center of the base. So the altitude, just remember, it is always perpendicular or 90 degrees to the base, right? As you can see, the base being labeled here. Then we have the actual angle where the space between the two lines where they meet, all right? So there's 3 of them. I did not label all 3. Likewise, the side, I only label one side, but we know there are 3 sides. Now the base is also considered as a side, right? Please note that the base is also considered as a side. Then we have the vertex, right? The point where the 2 lines meet. And there are 3 of them. And please note, even though the top is called the apex, it is also considered a vertex. All right, please note that it's just that a special name, which is the apex, is given to that because it's the highest point on the triangle. So types of triangles, again, you can pause here, challenge yourself, you can list as much as you can. And there are 6 of them that we'll be looking at. So you can try to list the 6. All right, I know the first 3 of them you would know very well, and probably the next 3 you may not know that well. Good, here we go. Equilateral triangle, isosceles triangle, scalene triangle, those 3 you might know very well. Then we have acute angle triangle, right angle triangle, and obtuse angled triangle. All right, so there we have a list of 6 triangles. All right, and now you can remember the last 3: acute angle, right angle, obtuse angle, right? That should give you an idea because we would have done angles not so long ago. So that should give you an idea about, the features of that triangle. Equilateral triangle, it has 3 equal sides. Now, this also means that the 3 angles automatically would be equal, right? So it has 3 equal sides and 3 equal angles. Now, if the 3 angles are equal, if I'm to ask what each angle is equal to, you should be able to tell me that, right? Because the total sum or the sum of the 3 angles is 180 degrees. So if the 3 angles are equal, you simply divide 180 by 3, and that would give you the size of one angle, right? And that is 60 degrees. So that's just some information there for you. Isosceles, it has 2 equal sides. And again, once 2 sides are equal, 2 angles will also be equal. All right. Scalene, this is an irregular triangle, as we would normally say. None of the sides are equal, right? It has 3 unequal sides. And if the 3 sides are unequal, the 3 angles will also be unequal. Now, acute angle triangle. This triangle has 3 acute angles. Now, we know what acute angles are. So we can say that this triangle has 3 angles that are less than 90 degrees. So let's go back to the equilateral triangle. We know that each angle here is 60 degrees. within the equilateral triangle. So we can also say that the equilateral triangle can be considered as an acute angle triangle because it has 3 acute angles, right? So again, additional information there for you. Right angle triangle, it has 1 right angle. So we know what a right angle looks like. It's 90 degrees, right? So this triangle has 1 right angle. Obtuse angle triangle, we know what obtuse angles are, right? They're greater than 90, but less than 180. So it has 1 obtuse angle. All right, so these are just some information based on triangles, which of course you would have to put them in your exercise books. So here we have some examples of triangles. And please note, triangles are classified by their sides and by their angles. Now, why we say they're classified by their sides is because we're talking about the sides. Equilateral, it has 3 unequal sides. All right, the emphasis there is on the sides. Isosceles, 2 equal sides. Scalene, no equal side. So the emphasis is on the sides. That's why it is classified by its side. Now, the one that is classified by, or the ones that are classified by the angles here, because we are speaking about their angles. Acute triangle, which is, it can be called also, it has 3 angles that are less than 90 degrees, as we discussed. All right, same for right angle, 1 angle is equal to 90 degrees. On obtuse angle, 1 is obtuse triangle has 1 angle greater than 90 degrees. All right, so these 3, they are classified by their angles. Right, so please note that the various classifications and why they are classified that way. Good. So what you would need to do also is draw examples of these triangles in your exercise book. Now here's a matching game for you, and I'd be happy if you can complete this the correct way without cheating, in terms of you place the presentation on slideshow and you look at them individually. So these would be the concepts, right? Has 3 equal sides, unequal sides, a plane figure bounded by 3 straight sides, has 3 angles measuring 60 degrees, has one angle being 120, and so on. So these are just some concepts, all right? Here are some answers. So you would have to match these concepts with the correct answers. So number 1, which one of them has 3 unequal sides? So you would have to pick the correct answer from here. All right, so when you do that and you finish all of them, you finish matching, then you go to the correct answers where you would see. So the first one is scalene, second one is a triangle, the third one is an equilateral triangle, or it can be considered as an acute angle triangle also. Number 4, obtuse. Number 5, 72 or 54. All right, so that's it for the game. All right, so I would be happy if you can complete this, you know, just like as it is here. Good. So homework, as I mentioned before, draw a diagram of each type of triangle under the various category. All right, so you complete that for homework. Good. So we complete there where we finish the basic information on the triangles. Now I'll move on. So construction of a triangle when given the length of sides. All right, so let me just get the workspace. Just a minute. Yes. So it's here. We'll go to this one here. So construction of construction of triangles when given the length of the sides. Now, please note the triangle has 3 sides. So most of the time you will be given the length for all 3 sides. All right, for example, if I'm to draw this triangle here, all right, you will be given the length for all 3 sides. Normally we label triangle A, right, B, and C. So normally you'll be given the length for all 3 sides. Let's say, for example, 50 mm, 70 mm, and 40 mm, right? So normally you're given the length of all the sides. However, if you're just given the measurement for one side, we would assume that it is an equilateral triangle and all the sides are the same, which is 70, right? So when you see you're just given one measurement, assume it to be an equilateral triangle, right? And you just use that measurement to construct the triangle. So step one, first thing we need to do is draw the base, right? So the base is 70, AB is 70, so we draw the base 70 mm long, all right, 70 mm long. Now, we must remember that we have to label also, right? We must remember that we have to label. So you label your line AB, which is 70 mm. Now, in order to get the other 2 lines that should be going up here and the next one coming here, we need to find the point C because the triangle is labeled A, B, C. So we need to find C, right? And in finding C, we need to use the pair of compasses, right? We go from A and open the pencil point to B, right? We open the pencil point to B, which is 70 mm, or you can just use the ruler and find 70 mm, right? It should be the same thing. So we scribe an arc above when we finish finding 70 mm. Scribe an arc above. Remember, we're looking for C using the same measurement because it's an equilateral triangle. So we find that distance. Then we go to B with the same measurement, which is 70, right? We go to B and we draw an arc to intersect that one, right? So automatically that gives us 70 mm also. Now where the 2 of them intersect each other, that is the peak or the apex of the triangle, right? We label that point C. Now, of course, from C, you draw a line to A, right? And then you draw the line to B. And that would complete your triangle, your equilateral triangle. All the sides are 70 mm. All right, so that is all you'd have to do in this case for this particular triangle. All right, you use 70 mm to obtain the sides. Now, please note the sides of the triangle, as you can see, they are a little thicker than the arcs that was scribed here rather. So that demonstrates line work. So when you are doing yours, you draw the sides a little bit thicker or a little darker, as you would say, than the arcs, right? The arcs must be very light. All right, they must be very, very light or very thin. So practice that as you are working. Good. Now there's another scenario here where we have a triangle, one triangle. Remember the triangles ABC, right? So the length AB, which is the base, is 50. AC, which is the left side, is 60. BC is also 60. Right? So we want to construct this triangle using these measurements that are given here. So I'll just get rid of this and we'll start from the beginning. Right? We'll start from the beginning. Now, so what I'll do, as we normally do, is start from the base. So the base is 50. So we draw the triangle, sorry, we draw the base 50 mm long. Right? We draw the base 50 mm long. And again, we need to label. Right? We label. Now, when we finish, remember we get the base. So we finish with the base. We go to AC now. AC is given as 60. Right? So again, let me just put a triangle here so you would know what I'm talking about, right? So that is one side and this is another side. So A, B, and the top there is C. Good. So AC, which is the left side, is 60 mm. So we take the pair of compasses, right? And we use the ruler to find 60 mm. So we go here now. Remember, we cannot use the length of AB anymore because all the sides are not the same. Right? So we open to 60, which, yeah, it was at 60. Yes. And we go from A and we scribe an arc above. All right, we scribe an arc above. So that gives us the distance or the length for AC. But we cannot draw a line as yet because we don't know exactly where C is. All right. Now BC is also 60. So what do you go from B and you intersect? And of course, when you finish there, you have the point C, which is the apex above there. So all you need to do now is draw lines from that point A and then to B. So there you have your triangle. Now looking at the measurements, this should tell you that it's an isosceles triangle because two sides are equal, right? Two sides are equal. So it's an isosceles triangle. Good. Now, what happens if all the sides are unequal? All right, if all the sides are unequal, let's say I'll just change the last one. Let's say BC now is 70. All right, BC is 70. So again, the steps are the same. All right, you draw the base, which is 50. All right, you draw the base, which is 50. You label A. All right, remember we always label. Good. Now we're looking for C. Remember, C is somewhere above. So again, we just use the pair of compasses and we find the respective measurements. And the first one, AC, is 60. So we go from A and we mark an arc. All right, now, again, we don't know the length. We don't know where 60 would fall. So we just draw the arc a little bit long, right? Just to be on the safe side. Good. Then you go again, you look for BC, which is 70. Right, which is 70. So you go from B using 70 mm because we're looking for BC. Right, using 70 mm. and we scribe an arc, right? We scribe an arc. So that will give us the point C. All right, we get that point C. So from C, we draw our lines. All right, from C, we draw our lines. So just by looking at the triangle here, you would see that the three sides are different in terms of their length. All right, so you can see that naturally. And this will tell you that looking at the three measurements there, this will tell you that it's a scaling triangle because all the sides are unequal. And looking at the triangle, you would see that the base is short, the EC is a little longer, and BC is the longest, right? Just looking at it, you can see that. Good, so that completes what we should be doing today in relation to constructing triangles when given the length of the sides. There are many other ways in which we construct triangles that we would look at during other lessons. All right, so this is what we will complete, we'll finish with for today. So you should practice on the ones that I explained, all right? And then, of course, you have your homework and your assignment here, all right? Your homework and your assignment. So please note, number one, you can see something different there, right? The perimeter. And you might be wondering, why is this different? So just remember what perimeter is. And of course, if the perimeter is this number, then you need to know how to find the length of one side. And that should tell you also that it's an equilateral triangle, both number ones, right? They're equilateral triangles. So you would find the length of one side by dividing the perimeter into 3, right? And that would give you the length of one side. The others, number 2, as you can see, they are isosceles triangle, right? Number 3, this should be number 3. I forgot to change that. Yes, so number 3, they are spline triangles, right? Now, the other topics that we look at will cover right angle triangle, obtuse angle triangle, and acute angle triangle, right? So we will not focus on those for now because you remember those are classified by their angles. And this construction is when you're given the length of the sides, right? So we would not focus on those for today, right? We'll do that in another lesson. Good, so that's it for today. I do hope that you find this video helpful in completing the constructions. And I don't know if you're hearing background noise and so on while this video was made. Just if you are hearing that, just excuse it. Of course, I'm at home and persons are here, and they would be talking very often and so on. So just ignore that if you are hearing it. Good. So thank you very much for being here. Goodbye.